Okay, for those of you that at some point try to do the final project or consider it like for a time, you should find like this problem very, very familiar. Okay, so here we know that there's a monkey and it's falling down, uh, and there's like a deer hunter trying to hit the monkey. Okay, so we're asked which is like the speed the dart should have for it to hit the monkey, okay, just before it falls down. So first of all, we need to figure out how long it takes to the monkey to fall down, okay? I'm gonna write out 1 here. We need to know how long it takes for it to arrive to the floor, okay, up to this point over here. That's what we want to know. So from here, we know that h is gonna be 10 meters, okay, from the beginning. That's from here to here. Okay, now we need to know that we know that also the ground is 11.2 meters from the original position. That means that this distance from here to this point is 1.2 meters. Why is it 1.2? Because the original was 10, so we just left 1.2 to complete like this 11.2 meters. Okay, that I'm reading here. So with that thing, we can start solving some things for the monkey. So for the monkey part, here we are. We know that the finishing position is minus 1.2. That's this point over here at the bottom. Minus 1.2 is going to be equal to the initial 10 meters. Then plus the initial velocity in y times t minus a half of the gravity times t squared. Okay, so we can assume that the monkeys just fell, so it had no initial velocity, so this thing goes to 0, and we're just left with 0 equals to 11.2 minus a half of 9.81 times t squared. If we solve for t squared, we're gonna get that t is gonna be equal to what? 11.2 over a half of 9.81, and the square root of all this stuff over here, it's gonna be 1.51 seconds. Okay, so that's the first thing we need to know. It takes 1.51 seconds for the monkey to touch the ground. Okay, so we need to, the dart should hit it before those 1.81 seconds. So let me change colors and keep on working with this only choosable one. Okay, so for now we know that the dart's gonna have an x component and a y component. Both are written here, the x component and the y component. We also know that the distance over here is 50 meters. Okay, so pretty much we can know the velocity index that this thing is gonna have. Okay, so that comes from the formula for x, and let's start like writing here for the dart. Okay, for the dart, we're gonna have that x equals x0 plus the velocity in x times t. The initial velocity is gonna be 0, position is gonna be 0. The final position is gonna be 50, and plus the velocity in x. I actually don't know it, so I'm gonna leave it as velocity in x. And time, I do know it, it's just 1.51 seconds. Okay, so solving for that, the velocity in x is gonna be 50 over 1.51, and that's actually 33.08. meters over second. Okay, that's just in X. We need to do exactly the same thing, but in Y. Okay, so let me change colors, and I'll use this green. For Y, here I am. Here. So for Y, I know that Y equals Y0 plus V0x times T. So we want to hit, well, I'm missing just the acceleration part. That's half of gravity times T squared. I should repeat that this sign is negative because gravity goes down. So we want to hit the monkey just before it hits the ground, okay? So we can just say that this Y is going to be minus 1.2. Initial position is going to be 0. Velocity in Y here, sorry. Plus the initial velocity in Y, which we don't know. We know the time, yes we do. That is 1.51 minus a half of 9.81 times 1.51 squared. Okay, let me just erase those things, those scratches. So from there, we just need to solve for V0y. Okay, and well, let me do the math, and it's gonna be, let me write it over here so I can have space. Here we will do minus 1.21 plus a half of 9.81 times 1.51 squared all over 1.51. This is going to be initial velocity in y, and this thing is going to be 33.73 meters. Over a second. Okay. So we know now, huh? I don't know what I'm saying anymore. We now have the velocity in y, and we do have the velocity in x. So we're just left with the easiest thing, that's computing the total, the magnitude of the speed. Okay, that's the thing that we're asked. We're not asked about the angle. Okay, so we know that the velocity, it's equal to the square root of the velocity in x squared plus the velocity in y squared. Because remember of this guy Pythagoras, he was like a very cool guy. And okay, we'll just say that's 33.08 squared plus 33.73. No, sorry, this is wrong. Let's screw that here. This one is 6.61. Sorry for that. Yeah, that makes sense. Plus 6.61 squared, and this thing is gonna be 33.73 meters over second. Okay, so there we go. And this is like a very long problem that it can cost you like a lot of trouble. So if you have like doubts or questions, don't hesitate and call me, please.